Everyone. In this video, I will explain how I have developed a LangSmith-like observability layer for a LangGraph workflow, which can work for any type of workflow by just importing a few functions, pre-built functions that I've developed, and by making some minor customizations. But absolutely no changes to the nodes that we create, the graph that we create, no changes at all. Okay, so the reason I wanted to develop my own observability layer is that I'm not comfortable sending my data to the LangSmith server. And second is that I want to see the information that I care about. Okay, I don't want to see each and everything that is happening inside the node or throughout the workflow. So this is a sample output coming out of that observability layer. So where the run ID is given, the start time of the flow is given, and information about each node that ran in that order. So first in my, I ran this for a agentic workflow where an LLM is there which has access to certain tools, and then it will decide whether it wants to call a tool. Then the tool node will be called, and then finally the LLM node will be called. So in this case, the question that I asked was what is 2 multiplied by 5? Then the node name, start date time, latency means how many seconds or microseconds it took, what was the input, what was the output coming out of that node, and in terms of tokens, if it is an LLM call, then what were the input tokens, output tokens, and total tokens, errors, if any, and finally the timestamp, which is same as the start. Okay, but this is the timestamp object. Then same information for the tool node except for the tokens. Tokens will be 0 because there was no LLM involved here. Again, third LLM call, same information we will capture. Okay, then we will also capture, it has also captured total tokens. How it will do is that during the run only, it will try to sum all the tokens for each category. All the input tokens will be summed and saved here. All the output tokens will be summed and saved here. All the total tokens also will be summed. Then the total latency also, which will be the sum of all the latencies of each node. Okay, so this is the information I care about, and this is the only information I have saved, and I will show you how I have developed this. But with minor customizations, we can try to enhance it and save a lot more information. But when we are reusing this for any other workflow, we don't have to make any changes to that workflow. Very minor changes, which I will show you. Except for that, our main core workflow will remain the same. Okay, so let's try to run this also once and see how the output is generated. So what I've done is that I've tried to define my graph and the collector function, which collects all this information and saves this into a JSON in this file, langgraph underscore graph.py, from where I'm importing both these methods. Okay, now I will do a collector.reset. I will tell you later in the video why I have to do it before every time I run this. And then I will just run this graph uh, using invoke by sending an input message. I'm printing a message. Then I will simply call collector.build. Okay, so when I call this build, then the final JSON will be created and I will show you how it looks like. So first we will run it through invoke. So if you can see, this is the final output coming from this, and this is the trace JSON, okay, which gets generated when we call collector.build. So collector is a class that I've created. I will show you how it works and how it like what is the code to develop that. Okay, so this is the output that I've just shown you in the beginning of the video. This is that output generated for this particular example. Okay, so the same process works for stream also. So don't worry whether it will only work for invoke. It works very well for stream or every other way of running a graph. It works very well. Okay, so now let's try to run this and see. Yeah, so all the node outputs are shown from stream. Then the final trace JSON is also showing in the same way. If I show all the output, it has collected everything. Okay, so this is the JSON trace JSON that we can use for our observation, that what happened at each step when I ran this particular question for my graph or for my workflow. Okay, so now I will show you how I have developed this. What does collector class contain and how does it work? Let's go to langgraph.graph. and see how it works. So I will start in a I will come to these two methods in the end, this class run collector and then this function instrument. I will come to the end, but before that I will show you how the graph looks like, although it is very straightforward. First, all the imports that are required. Then we initialize our LLM. I'm using Groq because it's free. If you want to understand how to use Groq in LangChain for free, please click on the link in description. Then we have defined few sample tools for our agent, which are multiply, add, divide tools. Okay, we will just create a list of tools. Then we will create a dictionary which has only the names of the tools. Okay, then we create an LLM which is binded with all the tools that we have defined. Okay, so this is the LLM call node, which will simply call LLM with tools LLM, which has access to all the tools, where we will send the all the messages. Okay, so when it runs for the first time, it has access to only the first in user input, but as and when it runs subsequently, it will have access to all the chat history. Okay, because we are using message state here, and message state is nothing but, if I show you, message state is nothing but a annotated list with add messages reducer, which means that every new message when we send in the output, it will be appended to this field. Okay, so this is what it means. So this is a predefined state class in LangGraph, which we can use for our chatbot kind of solutions. Okay, otherwise we can build our custom class also. So next is the tool node. Tool node, what it will do, it will take the state. In the state, in the last messages of the state, message of the state, in last element of the messages which is available in the state, if it has a tool call, then all those tools will be called. We will find that tool from the tool by name dictionary. Then we will call it, invoke it, and whatever output comes, we will save it in the form of tool message in the result. Okay, so basically there can be chances that the LLM decides to call two calls in two tools in parallel. So all those tools will be executed, saved in the results, and then in the messages, we will simply send that list as an output. Okay, so here we are sending the list of the output of this one in the list form. Okay, so this is tool node. Should continue, it totally just tells whether go to end or go to the tool node. If there is a tool call involved in the last message, then go to the tool node. If there is no tool call involved, then go to end. Okay, so this is that relationship. Then these functions also I will come later, but first let's complete our graph. So this is the class that we have initialized, which I will show you in a moment. Then we initialize our graph. Then we add the nodes. So here is the interesting part. This is the name of my node. Okay. And instead of calling the LLM call function, I will call the instrument function, which will call the LLM call function also. And it will do a lot of other things also, which will help in creating our observability layer. Okay. So what parameters we have to send it to is name of the node, then the function that should be called for this node, then the collector object of this class, then input extractor custom function, output extractor custom function, and token extractor custom function. Okay, same we do it here. We name this node as tool node, but instead of calling the tool node function directly, we call this function where we pass all this information. Now let's come to these functions that I've created. These are custom function. The reason I kept it outside of the collector or the instrument function is that later if we want to customize this, so if some user thinks that I want to customize the input that I'm getting from the LLM node, or I want to customize the output or the input and output from tool node, or the tokens that are generated, I want to customize that. For that reason, I have kept it outside of the main function, so that we can always customize it the way we want to. Or sometimes the kind of LLM that we are using, that also decides how the input or output is generated. So for that reason, we might have to make some changes. For example, I'm using a LangChain LLM, so this method works there, but if we are using some other LLM, this might not work. So we might have to change that. So let me explain how this works. So it will have access to the state. Okay. So LLM input means uh, the in the state messages, whatever messages are coming, all the messages always go as input to the LLM node. Always. Okay. So all the messages I'm just using uh, each message and I'm doing pretty underscore RE representation. So pretty representation means that it is a string representation which is designed in a way that it is very friendly to read. Okay, so pretty representation in a string format, and I'm just appending every output of all the messages. Let's say till now only around 3 messages have been generated. So all those 3 messages will be uh, converted into a string format, which is pretty, and appended into this string, and that string will be returned as the input, LLM input. Output will be just the last message. Whatever information has been saved in the messages, just the last message will be always be the output of the LLM, and then just a pretty representation of that. So for tokens, what we do is we take the last message, we find this attribute usage metadata. In my LLM that I use, usage metadata contains that information. But if you're using some other LLM, we might have to customize this function. So that attribute contains all this token information, and then we just simply convert it into a dictionary and then we send it. Okay, if I show you in the output, this is how it looks like. Okay, so this is coming from the this method. LLM tokens. Same customization we are doing for the tool node. Tool node, whatever to tool, only the last message goes as an input, not everything. Okay. So just we take the last message and we take the pretty representation of that. Output, only the last message. No, I think so whatever output we send, sometimes if multiple tools we have executed, so chances are that whatever output comes as a result of this. So this, if you notice, in input we are sending the complete state because we want to get access to all the messages. But here in the output we are only sending the result, which means whatever will be the output of that node that we are sending. Okay, so here result we will take, it can, chances are that it might be a list of messages. So whatever messages it has, then all those messages will be converted to pretty representation and then appended to each other, and then we send that as an output. So these custom functions we can always change according to our needs. Okay, so these methods we will call. Now let's go to the instrument method and then the collector class, run collector class. Okay, so let's come on the top. So have I missed anything here? Okay, so these are the nodes. Then we simply add an edge from start. It will start from the LLM call. From LLM call, there will be a should continue condition, which will decide either to end it or go to tool node. And from tool node, we will always go back to LLM call. We will never end this because the output of this one will not be human readable, or human might not understand what is output. Okay, so then we finally compile it. So let's come to the instrument method. Yeah. So these are the fields we send, what is the node name, what function to call to run that node, the collector object that we have created out of this class, then input extractor function, output extractor function, and token extractor function. Okay, so inside this we will define a wrapper which will have access to all the state and all additional information if we are sending. Then what we will do, we will run the collector dot start node. So let's open this also. So collector, it will whenever we define create an object of this class, it will initialize these fields from this reset. Okay, so I had to define this reset for a reason that I'm creating an object of this class only once, if you see here. So whenever I'm calling this graph, I'm using the same object every time. So this is the same object I'm using every time. So for that reason, if I don't reset it, then all the previous runs, information of all the previous runs will also keep getting appended and collected. Okay. So it will use the same run ID. It will keep appending all the nodes, which was not looking correct. So for that reason, I had to reset every time I'm running it. So if you see here, whenever I'm calling the graph, first I reset this. What reset is doing is this. It will reinitialize this information, which we want at init also whenever the object is created, and whenever we call reset also, everything will be reset. The new timestamp will be created, new UUID run ID will be created, and everything will be set to blank. There will be no further appending happening. Okay. So what method did we call here first? Start node. Okay. So this is a start node method. What it will do, it will only return the node of the name, the start time, which we will capture using time.time, and the input data. It will return that as a dictionary. So for input data, I'm calling this input extractor method, where I give access to all the state. If at all it is available, if not available, then the input data will be none. Okay. So this will be before running the node. Then I start a try catch so that if we run into any error, we can catch it. Now the node function will be called, where we give access to the state and any other additional information. So node function is the function that we give name to. If I come down here, so here which node function I want to call? I want to call LLM call for this one and tool node for this one. Okay. So where was I? Yeah, so we run this node, then whatever is the result, we send it to token extractor. To token extractor, we only send the result, but to input extractor, we send the state. Same for output extractor, we send the result only. Okay, so result will be just whatever output that node is giving. Let's say, for example, we see LLM call node. It is only sending the output of this in the messages, just the last message that is generated. Here also, whatever messages got generated by the tool as in form of tool messages, only those will be sent, not the complete state. Okay, so that only we will send. So tokens have been generated using token extractor method, whatever we have sent here for that particular node. For a tool node, we have sent a different method. For LLM call, we have sent a different method. Then we will call the end node. So what end node will do is this. It will again generate the time, because generally in LLM calls, some latency is there, maybe a couple of seconds, 1-2 seconds, or sometimes it is less than a second also, but it is always higher than a simple Python function. Like for example, tool call is a simple Python function. It will always take very, very less time compared to LLM calls. Okay, so we will just calculate the latency where we took the start time, okay, from node trace. Then we convert this into a desired format, and then we finally create the trace for that node. Okay, so node will be node name, then start date time in a desired format, latency what we have calculated, input what we got from this node trace input which we have sent here already, the full node trace we have sent, in which input will also be there, output whatever was generated, tokens, it will always be a dictionary, errors if any, and finally the timestamp. Okay, so this will be the trace that is generated. Then what we do is that we nodes list that we have initialized, we will simply send this dictionary to that nodes. We will append this dictionary to the nodes, and then the total latency, we will simply whatever latency we have got till now, we will add the current latency also to that. Okay, then if at all any tokens are there, then for each type of token we will append it. So key value, whatever token dictionary we get, then we will simply take the key, Okay, so total tokens is a element that we that has all the information, and from there we will just have all this value, and we will add this value to that. Okay, so this is the end node that is called. What else happens after this? Now we simply return the results because we are in a way executing the node only here, right? So whatever is the result of the node, this function, we have to return that also, so that our graph also smoothly runs. If at all we run into any errors, this is what we do. In for end, we capture the error, tokens will be 0, output data will be none, and whatever this input information, start node information we have collected, we will send it here. Okay, so this method will be called. And in this collector, have we missed anything? Reset is done, start node we have defined, and node also is done, and then the build. So what build will do is that it will simply return this result. So whatever we have collected till now in all these fields, we will simply return that. Okay, run id will be self.run id, start time whatever we have captured in a desired format, then self.nodes in form of a list whatever we have collected, total tokens. So all the information we have collected so far, by calling all these methods for every node, we will just send it whenever a build method is called. Okay, so these two functions will automatically take care of all our observability by just defining. So if you see here, I have not changed anything inside the nodes that I've created. So I simply can call any different nodes. Here, nothing related to observability is there. It is a simple function. We can run it independently also. The only difference is that when we define the node, that time we have to decide what method to call. We will simply not call the LLM call method or the function. We will call this instead. So if we build our graph differently without this, then the observability layer will be removed and the graph will still work fine. Okay. So this is about observability, custom observability in LangGraph, which is purely private. We don't have to establish any connection with LangSmith. We don't have to send any data, and we only want the output that we care about. Okay. I care about this output only. So that's why I've created it like this. So please let me know in comment section if there is any section that you could not understand. I will share the link of this code also in the comment section and in the description. And please subscribe to my channel for more such videos. Thank you for watching. Bye.